Good morning, everyone. Myself, Anandi, Assistant Professor, Department of Computer Science and Engineering of SA Engineering College. Today, we are going to discuss some of the gate questions of the subject Computer Organization and Architecture. First, this is the complete syllabus for the Computer Organization and Architecture. Among these topics, we are going to discuss about the addressing modes. So, when we take for the computer architecture, the main part is the instructions and how we are going to work on these instructions. So, in order to perform some operation on the instructions, we need an instruction along with the operands. So, to fetch the operand, that we are going to take the operand to perform the instruction execution. That is the main part. That is told by the addressing mode. So, what is an addressing mode? The addressing mode is the method used to specify the operand of an instruction. So from that we can take the operand. From that we can fetch the operand and we can perform the instruction execution. That is told by the addressing modes. We can fetch the operand from any place. It can be given directly in the instruction, or we can take from any memory location, or we can take it from the register. So we can take it from any location. So that location is given by this addressing mode. We have different types of addressing modes. So for any instruction execution, there are two things we need. First one is the starting address of the memory location, and second one is the effective address. This effective address is nothing but from the starting location at which position I can take the operand, or I can fetch the operand to perform the instruction execution. So here is the different types of addressing modes. We have implied addressing mode, immediate addressing mode, direct addressing mode, register direct addressing mode, indirect addressing mode, register indirect addressing mode, and indexed addressing mode. So we are going to take a look on each of every one. So first one is the implied addressing mode. So from the name itself, we could see that it is they're given inherently in the instruction itself. No need to go to any memory location or anywhere. The example of this instruction is a complement the accumulator. Accumulator is one type of the register. So complement means we have some content in the register, the accumulator, and all the contents is going to be a complemented. That is, we can get the ones complement of the instruction or the operand in the accumulator. We also have to clear the contents of the accumulator. So these type of instructions are what called as a implied mode instruction. That is, inherently the operation will be done on those operands. So we now need to go for any location to get the operand. That type of instruction addressing mode is called the implied mode. The second one is the immediate addressing mode. So immediate addressing mode is nothing but here is the instruction format. We have an opcode and an operand. So the operand will be specified in the instruction itself. We no need to go to any location to fetch the operand. The operand will be present in the instruction itself. The operand is nothing but the data on which we are going to perform the operation. So here is an example for that. The first example is load R1, hash 1000. Here the instruction is load. It is opcode is load instruction, and R1 is the register, and the value is 1000. We are going to load the value of 1000 into the register R1. Okay. Second one is an add instruction. So here the instruction is add R2, hash 3. What does it mean? When the operand value is 3, that is going to be added with the content of what is present in the register R2. So the operand is immediately present in the instruction itself. You no need to go to any memory location to fetch the operand. This type of instruction is this type of addressing mode is called as immediate addressing mode. The next type of addressing mode is direct addressing mode. So here direct addressing mode is we can directly go to a memory location to fetch the operand. So here is the format for this. So we have an opcode which says what type of instruction need to be performed, and we have an address location that specifies to a memory location. So we can directly go to that memory location from which we can find the operand on which the operation is need to be performed. The example is add R2, 3. Here R2 is the register name and the address location is 3. Here the value of A will be 3. So go to the memory location 3 from which we can fetch the operand and you can perform addition operation with the content what is present in the register R2. The next addressing mode is register direct addressing mode. So in the case of direct addressing mode, we are given with the memory location. From that memory location, that shows the effective address from which we can take the operand. So here, as the name implies, it is a register. So here we have the opcode along with the register, name of the register. So we can go to the particular register from which you can fetch the operand and you can perform the operation. For example is add R1, R2. So what does it mean? The two values are present in the register. So go to the register R2, fetch the content from the register and add a value with what is present in the register R1 and it will be stored. So here the address is present in the register. The next type of addressing mode is indirect addressing mode. So indirect addressing mode is here also an address will be specified in the instruction, but we cannot fetch the value directly from that address. That is only the effective address. We have to go to that address to fetch the operand. So here from the diagram itself we can know. So you are given with an opcode and then address value. Go to the address. That address shows the effective address of the operand. That is from that address you have to go to the next location to find out the operand. So here the address specifies only the effective address, not the address of the operand. So indirectly you can fetch the operand. This type of addressing mode is what called as a indirect addressing mode. So here is an example for that. Load R1, at 1000. So what does it mean? We have to go to the location 1000. In that location, you are specifying the address of the operand. So you have to indirectly go to that location to fetch the operand, and you have to load it into the register R1. Similarly, we can perform addition or any other type of the operation. So take the address from the effective address from the address location specified in the instruction and fetch the operand and perform the operation. The next is register indirect addressing mode. So here the content is specified in the register. So go to the address specified in the register. That will be the effective address which indirectly points to the address of the operand. Fetch the operand and perform the operation. Here also we have an example that the address will be specified in the register rather than the memory location. The next addressing mode is a indexed addressing mode. So here indexed addressing means you are given with the opcode and also an index value of the register. So that content is added with the address value, memory location value. So on index register value will be there. That memory location value will be added with the address, memory address value. Both the value will get the address of the operand. So this is what called as an indexed addressing mode. So these are some of the addressing modes we have seen. So but we have seen that different types of addressing modes is implied addressing mode, immediate addressing mode, then direct addressing mode, register direct addressing mode, indirect addressing mode, register indirect addressing mode, and indexed addressing modes. We have known about the different addressing modes. So, as I told earlier, we could fetch the operand from that position, from the which location we could take the operand. That is given by the addressing mode. Now, we could see some of the questions solved in the previous year in the gate questions related to this addressing modes. So the first question given is, so a processor with 16 GPR, GPR means a general purpose register. So we have 16 general purpose register uses a 32-bit instruction format. So here the instruction format used is 32-bit. That is the first given data. So 32-bit instruction format is used. Next, the instruction format consists of an opcode field, an addressing mode field, and a register operand field, and a 16-bit scalar operand field. Okay, so when you go for any type, we have different type of instruction format. So each instruction will follow different format. So here it is given as you have an opcode field followed by an addressing mode field, then you have a register operand and a 16-bit scalar. So these are the four fields given in the type of instruction. If any addressing modes are to be supported, the maximum number of the unique opcodes possible for every addressing mode is. So the question is, also for each and every question, it may be seen very big, but you have to read it once or twice to find out what data is given. So here is a simple question. The given is 32-bit instruction format and it consists of four fields. What are they? You have an opcode field, the addressing mode field, a register operand field, and a 16-bit operand field. Okay, to find out, and 8 addressing modes has to be used. We need to find out what is the maximum number of unique opcode that can be used. So, from the given data, we can find this easily. The total number of bits used by the other bits. I have 4 fields in the instruction format. So, what are the number of fields used that we have to find first? So, first is 3 bits used by the addressing modes. Okay. That is 8 addressing modes, so 2 to the power 3, so 3 bits. Then you have 4 bits for the register operand. The register usually takes 4 bits. Then you have 16 bits for the scalar operand. So what are the data given? 2 power 8 addressing mode, so it is 2 power 3. So 3 bits for the addressing mode. For the register, you have 4 bits for the register and 16 bits for the scalar. So totally sum up all this, we are getting totally 23 bits. So among the 23 bits are used. So now we need to find out what are the remaining bits that can be used for the opcode. So total number of the bits in the instruction is, the instruction format is given as 32 bits. So 32 minus this 23 which gives you 9 bits. Okay. So to find out the maximum number of opcode, we have to take the power of 2. So 2 power 9, which gives the value is 512. So this 512 unique opcodes we can form. So you have to check what is the instruction format, how many bits are used, among that how many bits are used, and how many bits we can use. Now we are given with the second question. This is also an easiest question. A processor has 64 registers and it uses 16-bit instruction format. In this question, the instruction format is given as 16 bits. It has two types of instructions, the I-type instruction and the R-type instruction. There are three different types of instruction, the I-type, R-type and the J-type instruction. Here we are going to talk mainly about the I-type instruction and the R-type instruction. And each I-type instruction contains an opcode, a register name, and the 4-bit immediate value. So here the I format is given as what I know. You have a register, opcode field, a register name field, and a 4-bit immediate value. The next R type instruction contains an opcode and two register names. Okay. So if there are 8 distinct type of I or type of codes, then the maximum number of a distinct R type opcodes. So here also we are going to find out the opcode only. So what are the given data? The instruction formatted is 16 bits. And there are two types of instructions. One is the I-type, another is the R-type. In the I-type instruction, you have an opcode followed by a register name and an immediate value. Whereas in the case of R-type instruction, you have an opcode followed by the two register names. So they are given the opcode for the I-type instruction, that is 8 distinct values are used. They are going to find out the number of opcodes for the R-type. Is clear? So now we are going to solve this problem. So the immediate instruction, what is the format? You have an opcode followed by a register and also an operand. So when you go for the log value and take the ceiling, we can get the register which is of 6 bits and the operand value which is given in the question is 4 bits. Okay. So altogether instruction format is only 16 bits. So 2 power 3, that is 8 possible light type instruction into the register value 2 power 6 into the opcode field, the operand field, which takes 2 power 4, plus for the register format, register type instruction, R type instruction, we does not know the number of the opcode in the R type. So I have taken that value as n into. For the register, the number of bits needed is 6. So we have two registers in the R type instruction, 2 power 6 into 2 power 6. All those values combined together should be less than or equal to 2 power 16 because the maximum permitted value for instruction format is 2 power 16. So this is opcode 3 bits. So 8. So 2 power 3 into 6 bits for the register, 2 power 6 into 4 bit for the operand, 2 power 4. Plus for the R type instruction, I does not know the opcode value now, so it is taken as n into register 2 power 6 into 2 power 6. All those values combined should be less than or equal to 2 power 16. Now sum up all these values, all the 2 powers. So 2 power 6 plus 4, 10 plus 3, 13 plus n into 2 power 12, which is less than or equal to 2 power 16. Now I've taken the common value outside. 2 power 12 is taken outside. So the 2 power 12, 2 plus n. So all this combined together, we get the value of 2 power is 14. So what does it mean? The value of n should be less than or equal to 14. So in the question, you are given that what is the maximum number of the distinct R-type opcode we can get? So we should go for the maximum value. So n is less than or equal to 14. So the maximum value that can be taken for n is 14. So 14 opcode values can be taken for the R-type instruction from this question. Next question. So when you go for this question, we could say it is a language question, C language question, but indirectly it means addressing mode. So the given question is consider the C struct defined. So you are given with the structure. So what are the things given in the structure? The name of the structure is data. So you have 3 fields here. First one is the marks field. Second is the character grade field. And third one is a number. And we have created an object for that. So let me explain that. So this is the structure of this. Okay, so again, its name is data. It has 3 fields. The first one is the marks field. The second field is the grade, and third one is the C number. Okay, this is the given data. And that object created is of the name student. Okay, so now we can go to the question. The base address of the student is available in the register R1. So the base address of the student structure is available in the register R1. This would be the base address. The field student.grade can be accessed efficiently using. So, if you are given with the base address, you have to go to the some other field in that particular data. How it can be asked? That is a question asked. So, what are the different types of answers given? First, we can go through the answer. First one is the post increment addressing mode. Second one is the post decrement addressing mode. Third option is the register direct addressing mode. Your fourth option is the two's indexed addressing mode, where x is the offset value given in the two's complement representation. So now we can go to this question. So what is asked? You are given with the structure. The first field is a marks, second field is a grade, and third field is a C number. We have to go to the student got grade. How we can go to that? There is a question asked. Now you consider this is the value of the base register given. So that is stored in the register R1. Okay. Now we have to go to different options. First one is the post increment mode. So what is the post increment mode? We can go to the next position. So I am here at the starting position. If I use the post increment mode, I can access only the marks field, but that is not our target. We have to go to the grade field. So first option cannot be used. What is the second option? Pre-decrement addressing mode. It will go to the previous position. So that is also an apt one. Third one, register direct addressing mode. So register direct addressing mode means, as we have seen earlier, we are given the register value. So from that register, you can take the operand. So here it is given the base register. We could go only to the marker. So that also cannot be considered. So the last option is indexed addressing mode. XR1, where X is an offset represented in the 2's complement 16-bit representation. So I have to add some value with this base address register to access this value. So the X is the offset value. If I add that offset value with this base register value in the R1, I can go to the particular location to access the grade. So this is the correct option which you can choose. So this is how you have to analyze and find out from the different options. So the answer is D. The direct access is possible only with the index addressing mode. Next question is, so consider a RISC machine where the instruction is exactly 4 bytes long. So each instruction is 4 bytes long. This is a given main thing. Okay, 4 bytes long. Conditional and unconditional branch instructions use PC relative addressing mode. The second point is PC relative addressing mode is used. And with an offset specified in bytes to the target location of the branch instruction. Further, the offset is always with respect to the address of the next instruction in the program sequence. Consider the following instruction sequence. So you are given with the instruction sequence, and the question is, if the target of the branch instruction is I, then the decimal value of the offset is. Okay, so we are given with the set of instructions. You are going to execute the instruction, and we are going to find out, if I go back to the value of 5, what is the offset value that is needed. This is a given question. Okay. So here the main things you have to consider is what is the length of the instruction. The instruction is exactly 4 bytes long. That is the first given data. Okay. The second data is, it is using PZ relative addressing mode. So what is called PZ relative addressing mode? PZ is the program counter. So how it is used? So the program at the starting of the execution, the program counter will have the address of the first instruction. So when you started the execution of that instruction, the program counter will point to the address of the next instruction to be executed. Then when you enter the second instruction, the program counter comes to the address of the third instruction to be executed. So this is how the value of the program counter will be incremented. So here it will be 4. So initial value of the program counter plus 4. So let us go to the question. The first instruction is I, which is an add instruction. Second is I plus 1, which is an subtract. Third one is a compare. Fourth one is a branch of equal instruction. So let us consider the I, first instruction, starts with the memory location 1000. Okay. So before starting the first instruction, the program counter will have the value as 1000. When I started executing the first instruction, the program counter will have the value as 1000 plus 4, which is 1004. The next instruction, I plus 1, will be at the location 4 bytes long, so it will be 1004. So when I started the next PCP program counter will go to the value 1008. Then when I execute I plus 2, which is at the location 1008, the program counter will point to the address of the next location, which is 1009. 12. Now I plus 3 will present in the location 1012. Now when I start fetching the instruction at I plus 1, that is 1012, your program counter will point to the location 1060. Can you understand how it goes? When you take the current instruction, your program counter's value will point to the address of the next instruction. So it is 1060. So when I execute I plus 3, when I am at the last instruction execution, your program counter will be 1016. Okay, we have come to the end of the instruction sequence. Now, what is the question? If the target of the branch instruction is I, I have to go back to I, then the decimal value of the offset is. What is the decimal value of the offset? So the formula is not, in order to get an effective address, what you have to do? You have to add the offset value with the program counter value. So the effective address is 1000. The program counter value is I have 1060. So I have to add some offset value. We can take it as an offset value. So that I have to go back to the location of I, which is 1000. So now taking this into the execution, what I can get 1000 minus 1060, which is the offset value. So here the offset value is to be minus 60. That is, the displacement value is minus 60, so that I have to go back to the location I. Okay. So sequence. What is the sequence? What is the current value of the program counter? So the relative offset value has to be minus 60. Next question is, we are given with the hypothetical processor and given some instructions. You have to find out what type of addressing mode can be used to solve this problem. So consider a hypothetical processor with an instruction of the type, which is a load instruction. You have a register R1 and R2. You have a register R2. So contents of the R2 is added with the value 20 and load the value to the register R1, which during execution reads a 32-bit word from the memory and stores it in a 32-bit register R1. And now the effective address of the memory location is obtained by the addition of a constant 20 and the contents of the register R2. Which of the following best reflects the addressing mode implemented by this instruction for the operand in the memory? So when you read this question, it has a 4 to 5 lines, so it's a big question. But what is given in the instruction is explained here. So result, it is a 32-bit register. The effective address of the memory location is obtained by addition of a constant 20 with the value in the register R2 and the content is loaded to the register R2. So you have to find out which addressing mode can be used to implement this instruction type. Okay. So the options given are the immediate addressing mode, register addressing mode, register indirect scaled addressing mode, and the base indexed addressing mode. So first consider immediate addressing mode. So immediate. Immediate means the value will be given, the operand value will be given in the instruction itself. So here it is not given in the instruction. You have to add the value 20 with the content in the register. So this is not a correct option. B, register. The value is not stored in the register. You have to add an offset value. Register indirect scale also, it will not suit. So the correct option is your base index addressing mode, where the register value, the content in the register will be taken. The value of 20 will be added with the content of the register to go to the particular location to fetch the operand. So the option which best suits the question is option D. So the value of 20 will act as the base and the content of the register will be added in order to get the effective address to fetch the operand. So this is how from the question we can analyze what are the different addressing modes can be used. So we could see some questions later. Thank you.